Does this have any relevance to the water crisis? You bet. Let me give a couple of examples. Almost every day there is some comment on the news or in the paper about the so-called water crisis. But let us just do a few quick calculations. We know that 1 millimetre of rain falling on 1 square metre delivers 1 litre of water. If we take a typical house with a land area of say 1,000 square metres, and keeping round figures, a rainfall of 1 metre, that means there is 1 million litres of rainfall on that block. An average house will use around 350,000 litres of water per year, which is only 1/3 of the water that has fallen as rain. Do the same calculation for our dams. Typically only a few percent of the actual rain that falls ends up in the dams. The reasons are clear. We may do our calculations on average rainfall, but rain is far from average. There are many small rainfalls of just a few millimetres which do little more than wet the surface and the water evaporates away. Slightly heavier rainfalls will wet the ground, but there will still be no runoff. To get runoff, there must be enough rain to first saturate the ground, and then the excess will start to flow into the dams. But if the rain is too heavy, the water will again be lost by flooding. And then, of course, any water that actually reaches the dam will evaporate away. Dams are an intrinsically inefficient way of storing water. And yet we just accept that this is the nature of the world. The radar has not picked up on the problem. But just look out of my window, trees and plants growing quite happily. I live in an area with less than 1 metre of rainfall, yet evaporation is over 2 metres. It is really marginal desert country. How is it that when the evaporation is double the rainfall that anything can grow at all? Surely it should be a desert. Well, no, there are definite mechanics which allow the plants to grow. It's all to do with how the water is stored and transported in the soil, and I will come back to this later. The mechanics of how this all works were well understood, at least at the instinctive level, by tribes living in the desert area of North America prior to the white man. But the current point is that this is not the subject of the intense research which it clearly deserves. It is a failure of emission resulting from the process of reductionism and the vertical hierarchy. Yet, as I will show later, there are other areas of the water puzzle which don't even hit the radar. No one seems to bother to ask for the information. The tribes living in the North American deserts used to manage perfectly well using simple but effective technology. An aspiring PhD student could readily get funding to study some mainstream topic like the variability of emission rates from a dripper system under cyclic pressure variations. And probably someone somewhere in the world has already studied that topic in detail. But try and get a grant to go to Las Vegas to study the technology of native tribes. This would not even pass round one of the screening process in the finance committee. Yet their simple but effective technologies could save more water in our urban gardens than any refinements to drip irrigation. This is one of the weaknesses of large and powerful organisations. If an approach does not fall into an established and neat little box, it never gets into the radar. It is a failure of emission of the communal intelligence system. The other great weakness is simplification. We talk about water as though it were some simple fluid, but it is not. We have these little mental pictures of the water molecule, one big ball and two little balls stuck together. Our image or model is that these molecules can roll over each other so the water can flow as a perfect fluid. We think it flows just like grains of sand in an egg timer. Science is based on developing models of the real world. These models are then used to create highly sophisticated predictive systems. The process of science is incredibly rugged. Experiments have to be duplicated in independent laboratories, and ideas and concepts subject to the most rigorous peer review before they are accepted. Science rarely gets it wrong, but the models are still only a simplification of the real world. Sometimes the difference between the model and the real world may appear to be very slight, but can have just mind-blowing implications. Our simple model of water is just one example. Water molecules are not some sort of mini golf balls, They are made up of even smaller particles which interact with each other. Electrons are shared between molecules to form a strong three-dimensional structure with mechanical properties like a steel chain. Water is not a simple fluid. It has some properties of a solid. Is this some academic nitpick? Absolutely not. It is this mechanical property which enables water to be pulled up to great heights in trees and plants. If it were not for this, there would be no plants and no life on Earth. It is the one single property that keeps you and me alive. It is also the key property which enables us to use water in a more effective way. It is at the heart of the solution of the water crisis. How do we even discuss this issue of communal intelligence and how understanding it better can lead to resolving the world's water crisis? At best, the discussion could become abstract and lacking in reality, and at worst create tension and aggression. Water is ultimately controlled by governments and their entities. They react with all the warmth and friendliness of 2 tons of very angry, charging hippo to any suggestion there may be some failure in the system. Governments are very skillful in handling criticism of the system. If they feel they are under attack, their first reaction is denial. They go into a highly effective defence mode, attacking the attacker rather than resolving the issue. Denial is not a river in Africa. So instead, over the next few episodes, I'm going to analyse the case of a small eco-village which has to manage all its water requirements. It happens to be where I live, so I do have some knowledge of how it all works. I'll look at how we collect clean water for drinking, manage our sewage and wastewater without contaminating our water supply, converting our waste into a valuable resource. There's no water or sewage utility, so we have to do this all ourselves. I'm not suggesting that the technological solutions we have adopted to solve our problems can be directly applied to a large city like Sydney or Los Angeles, though much could. But it is the thought process, the study of our communal intelligence, that is totally relevant and important.